section 1, chapter 2, lesson 2, operations of functions, part 1. So now we're talking about different operations to do with functions. You have the sum of functions, difference, product, and quotient. And we're going to talk about domain and range effects of each. So the sum of f and g, f plus g of x equals f of x plus g of x. That simply means if you know what f of x and g of x is, you're going to combine like terms and make a new function. Conversely, difference is the same thing, but you're minusing the two. Biggest thing here when you're minusing g of x, if it's more than one term, you have to distribute the negative, right? You're subtracting the whole function. Okay, product you will distribute. Okay, you'll multiply in, and then quotient it'd just be f over g. You have to watch out now because g can't be 0. Okay, because g of x, if it's 0, it's a non-permissible. So there's some things to think about when you're doing these. Okay. All right, so investigating the sum and difference of two functions. Okay, so part 1, f of x and g of x are defined as real numbers. Okay, the table of values below shows the values of f and g for certain ones. So we're going to go ahead and look at these as best we can here. And we'll go to right there. Should be good. Okay, so the thing is, people get confused in this is that we don't know what these functions are. We don't know what their values are, but we know what the outputs are, and that's all that matters. So what I mean by that is x is our input, so the inputs don't change. My inputs of every function is your independent variable. The outputs is what changed. So if f of x at -4 is -7, and then g of x at -4 is -7, then we would say, essentially, it's -7 plus -7, because you're adding the f of x and the g of x outputs. So this is the case where we have the outputs already. We don't have x and stuff to combine. Okay, just remember, like people continue to forget, these are y's, outputs. We'll call y1, y2 because they're two different functions at y's. Okay, so then you get -14. If I go f minus g, -7 minus a -7 is +7. You get 0. And I'll just continue filling this out here. So we get -5 plus -6. You get -11. -5 plus 6, you get 1. Okay. -3 plus -5, you get -8. -3 plus -5, or sorry, minus a -5 means +5 is 2. And we just keep going here. So we're going to get -5, 2, oh, -2, sorry, 1, 4, 7, 10. And this one we're going to get 3, 4, 5, 6, 7, 10. Okay, whoops, 7, why did I say 10? 8. Okay, and so that's just kind of their growing, so we'll go and plot these points here. So the point of -4, -14, so -14 is down here, it's right there, -4, -14. Then I have -3, -11, it's right there. -2 is -8, right there. -1 is -5, right there. 0 is -2, right there. 1 is 1, right there. 2 is 4. 3 is 7. And 4 is 10. And so that's roughly what this guy looks like. It's a line. The slope is 3 for that one. Switch colors for this guy. So my second function, okay, would be -4. Oh, sorry. So this is this one. We just did that one, yeah. Okay. So then, all right, -4, 0, right there. -3, 1. And so it's going to go like this. It's slope of 1. They share at 7 there. And then keep going here. So there's your two new functions. So we just did f minus g, and then I'll turn it back to black here, and that's this one. They went ahead and graphed all the types though, so let's go ahead and do the original. Okay, that's blue, so -4, -7. It's going up by 2 every time. Okay. So that goes through there. And let's go ahead and just do the last one here in red. This guy we'll do in red. G of x, it's going down each time. So -4, -7, or sorry, up 1 each time. -4, -7 again. So right there, -6. Yep. Okay. And that one looks like this. You can draw those more solid lines if you like, but that's just kind of the illustration of all those functions together. So they're all linear. So one thing to notice is that if they're both are linear, and you're adding two linear functions together, they got what? Something linear again, right? Because it didn't change the degree. Because our highest degree on a linear is just x to the 1. So if I'm adding x to the 1s with other stuff with x to the 1s, it's going to be all x to the 1s in terms of common terms or like terms. So that's why everything's linear on this. If we multiplied, then we may get a what? A parabola, right? Because we're multiplying linear factors. X times x gives me an x squared. Then we could look to having maybe a parabola change, okay? So these questions here, plot the points, so we did that. Plot the points, so we did that. And we did the tables, and we plotted that. So we did A, B, C. Good job. Okay? All right, so D. Okay? D, sure. Yeah. So functions f and g in the previous page, f of x is 2x plus 1, so they told you what the functions are, and g of x is x minus 3. Write the expressions for those functions now. So they told you what those actual lines were. Okay, so if I'm doing 2x plus 1, oops, we're in red, but that's okay, and I'm going to add x minus 3. This is f of x plus g of x. That's what we're doing here. So your f of x plus g of x function simplified is 2x plus 1x is 3x, which makes sense because that line we drew had a slope of 3, remember? 1 plus -3 is -2. So f plus g of x is the line of 3x minus 2. Then we have f of x minus g of x. That gives us 2x plus 1 minus, put a bracket here so you distribute the negative, x minus 3. So that gives you f minus g of x. 2 minus 1x is x. 1 minus a negative is plus, so plus 4. So you have 3x minus 2, x plus 4. Okay, I really don't think we need to do part E. You guys can know what lines look like, but they just want you to put this in your calculator. If you put all 4 of those lines in your calculator, you're going to get the same picture we just drew. So this is just kind of, if you want to try that, you can, but we're not going to do it right now for the video. Okay, state the domains and ranges of the functions. F plus g of x and f minus g of x. So what is the domain of f plus g of x? And what's the range? We'll write it in set builder notation. They're lines. Is there restrictions on x? Nope. Is there restrictions on y? Nope. Everything's all real. So domain would be xer. The range would be yer. Okay, and f minus g would be the same. Okay. All right, determine the values of f plus g of 10 and y equals f minus g of negative 10. So we're just plugging those in. So you can plug those into the beginning or the simplified, it's not going to matter. We know f plus g is 3x minus 2. So if I'm doing f plus g of 10, I'm plugging 10 in for x in the simplified version, like so. 3 times 10 is 30, minus 2 is 28. So 28 is f plus g of 10. So if you're lost, this is 3x minus 2 right here. the x is replaced by a 10, because that's what they told us x is going to be. Okay, f minus g of negative 10. So we take our f minus g, which is x plus 4. We put a negative 10 for x. We get negative 6. Okay. All right. In this example, the sum and difference of two functions of degree 1 is also degree of 1. Can you find two functions of degree 1 whose sum and difference is not a function of degree of 1? This is one thing that's food for thought. This is not crucial. But you can see that whenever you're adding lines together, you still get a line unless what? What could cause you not to get, and this is actually technically wrong, but I'll explain what they're trying to say. Correct, when your x's cancel. So if my f of x was 3x plus 2, my gx was negative 3x plus 2, and I added them, my x's would cancel, right? Because 3x and negative 3x. So 2 and 2, though, would give me 4, which is actually still a line technically. It's that flat line with no slope. So that's a little bit wrong on this one. Correct. Y equals 4 would be a horizontal line. You'd have a constant left. Okay? But that's the idea, though, of your degree changing. Okay? Your degree could change if your x's cancel. Okay? So moving on here, part 2, we're going to look at the parabola situation now, where things get a little bit, I don't want to say messier, but a little more complex. So the graph of two quadratic functions, f of x and g of x, is shown. The points marked with the dots have integer coordinates, so that just means that they're whole numbers. The reason they're telling you that is because I hate when they do this and they don't tell you, but this is going by 2's. So that means if that's an integer, that has to be what? 1, right? Okay, that's good. So you guys are fine with that? That's good. I'm not fine with it. All right, the graph, so we said that they're integer coordinates. Okay, use a graph to sketch the graphs of f plus g of x, f minus g of x. They like to do these. I've seen this a couple times in the diploma, okay, where they give you the pictures and they want you to do f of x plus g of x. And so what you do is, what doesn't change? The x's. Your x is your inputs no matter what. And so if I'm doing f of x plus g of x, what you're going to do is, let's just take, for example, let's start at 0. F of x is this guy, okay, and then g of x is this guy. We're going to add those for a second. So I go, what is 0 plus 4? And it's 2, 4, right? 0 plus 4 is 4. So the dot stays at 4 for f plus g. So right now I'm going to do blue with f plus g. This is how you're doing it when you're not doing functions. We don't know what they are. Okay? We're not plugging in points. You're using the outputs of the graph to figure out the new point. Let's try another one if you're confused there. So let's look over here. Let's look at negative 3. Or sorry, yeah, this is negative 3. So negative 3, we're doing f plus g. So f is up here. F is 24. Okay, g is 1. So it's at 25. Yep, so right here, 24 is what f is. G is 1. 24 plus 1 is 25. The y values. That's 1, right? So right? And then that's 24. We're adding the y's, right? We're adding the outputs. Yeah. Okay, this one. Okay, my f of x is 12. So I'm at negative 2 right now for following. Okay, or yeah, negative 2. 12 plus 4. 12 plus 4, 16.
Oh, so use both the graphs.
Correct. We're doing f plus g. We're doing f plus g right now, yeah. Okay, the negative 1 is really close. 2 and 3, or 4 and 5, excuse me. 4 and 5, right? For these two spots. 4 plus 5 is 9. So it'll be right here.
I feel like I'm going to ask you a question, but why do you, what y's are you picking from? Like the negative 1. Am I just not seeing it?
So I'm picking any x I want. There's no pattern to which ones I'm picking right now. It doesn't matter. I'm just going through right now. I just started left to right. So I did 0 first, and I was just working this way, and then I'm going to keep going this way and just finding dots. But it doesn't matter which ones you do in order. Okay. So now I'm over here. We already did 0, so I'm going to jump to 1 now. Okay. 1. I have a 0 and a 1. See that? So for addition, does order matter? No, so we don't have to really care which one's F, which one's G for this, because order doesn't matter. When we do subtraction, order does matter. Okay? But 0 plus 1 is 1, so we have a dot here still. Okay? Look at this one. Negative 4 and positive 4, 0. And I think this is the last one we can do here is negative. It's positive 3. I get negative 11, positive 12. So I get 1. Maybe we can do one more here. Let's see. Negative 20 and 24, so 4. Okay, so you kind of see, whoops, still has a parabola look to it. That blue is your F plus G. Okay, let's go ahead and give you a second because I feel like a lot of you guys are processing, trying to get this down. I'm going to pause the video. I want you to try F minus G on your own, see if you can get what you're looking for here. Okay, as you guys are working on that, I'll just kind of do some of mine as well here. So I'll do mine in green here for F minus G. So order doesn't matter this time, so you want to kind of stay with F, okay, and work away from it. So I have 24 minus 1, so 23. Okay, next one over, 12 minus 4 for 8. Next one over would be 4 minus 5. 4 minus 5 here for a negative 1. Then here I have a 0 minus 4. So that's negative 4. Okay, and then next one over, we have 0 minus 1 for negative 1 again. Next one over, we have 4 minus negative 4 for 8. And then we have 12 minus a negative 11 for 23. And we roughly have this picture now. Okay, so that's what your F minus G would look like. Okay, any questions on that? Okay, so then you can kind of, if you looked ahead, they gave you the functions now. That B was 2x squared minus 2x, or F was, sorry, and G was negative x squared minus 2x plus 4. Write the expressions of F plus G and F minus G. So F plus G, we're just combining like terms here. 2x squared plus a negative x squared is just a positive x squared. Negative 2x plus a negative 2x is negative 4x. And then it's adding, so it's plus 4. Okay, so that's our F plus G. Interesting fact here. What does this factor to? X minus 2 squared, right? That's why it bounced. That's why it bounced, remember? The parabolas that have a single 0, they bounce off of it. Okay, so just keep that in mind. Your F minus G. So order matters here. So 2x squared minus a negative x squared is positive, so 3x squared, because you're adding the negative x squared there. Negative 2x plus, negative x minus a minus, which is plus, that's gone. Okay, and then we have 0 minus 4, so you're here. Okay, a couple things I can check this one now. Look at the green line. What was the green line's y-intercept? Negative 4. Which of these parabolas was the steepest? The green one, because 3 is the biggest of the A's. That was a 3, that's a 1, that's a negative 1, and that's a positive 2. Okay, all things to consider there. Okay, when you're doing your parabola stuff. Okay, any questions there if we go to C? What do you think about, Will? Okay, so these parabolas are a little bit little bunch, but you can see the differences. All right, so look at C here. So D and C is using the graph calculator to compare. Trust your picture's fine. You can do that on your own time if you'd like. State the domains of the function. So what's the domains of the parabolas? It's all reals, right? Parabolas don't have any problems. We can have any x's we want. They didn't do range. They just said just the domain here. And that's for both of those. It's going to be XER. Okay, in this example, the sum and difference of two quadratic functions are quadratic functions. Can you think of two quadratic functions where there wouldn't be a quadratic? Again, if they canceled. So if I said negative 2x squared x or plus 8 is my f, and I said my g was 2x squared minus 9, if I added f plus g, my quadratic would be gone because the 2x squared just cancel. Okay, we're just going to do a couple examples and we'll be done today, so a little bit on the shorter end. All right. Okay, so working to the examples here. So consider the functions x cubed minus 2x squared plus 6 and x cubed minus 2x plus 6. So there's just a square difference there. For XER, determine the expression for f of x plus g of x. So f of x plus g of x is expressions. That means with x's. So I'd have f plus g of x would be equivalent to 1x cubed plus 1x cubed is 2x cubed. Negative 2x squared, there is no 2x squared, so it just stays negative 2x squared. I don't have any other x's, so it just stays negative 2x. 6 plus 6 would be 12. So there would be your simplified expression for f plus g of x. Okay. F minus g of x. Your x cubes would go away because you'd minus them. You'd have a negative 2x squared because there's no other x squared, so it stays that. You'd minus a minus on the 2x, so it would be plus 2x. And then lastly, 6 minus 6 would be a go away, so that's all you have left there. Okay, and I will just say in general, guys, I know a lot of issues and a lot of things missed on diploma stuff is just simple negative, things like that. So just be really really diligent in your organization and distribution of your negatives and stuff so you don't miss simple things that you shouldn't miss. All right, so complete the following statements. F of x plus g of x is a what? Sum, good. And can be written in the form of, what are they wanting there? They're just wanting the answer we put. So they just want 2x cubed minus 2x squared minus 2x plus 12. And then f of x minus g of x is a difference. Okay, of f and g, and can be written as, so they said negative 2x squared plus 2x, and then you also could pull the 2x out if you wanted, and it would be even a negative 2x actually. It could be x minus 1 if you wanted to like simplify it a little bit. Okay. All right, so evaluate is now, once you have those expressions, you will plug in negative 2 in for x. Okay, there's two things I'm going to tell you though. You can also find out what f is at negative 2 and g at negative 2 and add them then as well. So you could do the expression, plug negative 2 in, or you can find out what f is at negative 2 and g is at negative 2 and then add, and you can do that as well. They will give you the same answer. I will show you what I mean because you guys look confused and tired. Okay, so f plus g of negative 2. So what our f plus g, what was our f plus g function again? 2x cubed, right? 2x cubed minus 2x squared minus 2x plus 12, right? So you can do that, and you can plug in negative 2 now. So negative 2 cubed is negative 8. So I have 2 times negative 8. Negative 2 squared is 4. Negative 2 times 4. Negative 2 times negative 2 is positive 4 plus 12. So I have negative 16, negative 24, negative 20, negative 8. So I get negative 8. Okay, when I plug into the expression. Now I was telling you, if you go look up at f, so f was x cubed. So just a reminder, f was x cubed minus 2x squared, right? Plus 6. That's what f was. If I put negative 2 in here, I get negative 8. Negative 8 plus 6. So f of negative 2 is negative 10. You okay with that? G is x cubed minus 2x plus 6. If I plug the negative 2 and I get negative 8, I get plus 4 plus 6. So G of negative 2 is positive 2. So what is f of negative 2 plus g of negative 2? What's negative 10 plus 2? Negative 8. See what I'm saying? You can plug into the simplified expression, or separately, it's still going to get you the same spot. Okay? All right, so f minus g of root 6. How nice of them to put a radical in there. So we have our, what was our minus equation again? Okay, at least it's nice. Okay, we're here. So negative 2 root 6 squared plus 2 times root 6. This we can't do. 2 root 6 is going to be 2 root 6 there, but we can square that radical there and it goes away, which is nice. So the simplified answer here is going to be negative 12 plus 2 root 6. And that's your exact value. Just leave it like that. I'm not going to do the other way this time. I already showed you that once, but you still could do the same thing we did before. All right, last example here. Okay. All right. Multimedia production company produces DVDs which cost $3 per unit. The fixed costs, including graphics, are $10,000 irrespective to number of DVDs produced. So it doesn't matter how many you produce, it's 10,000 fee. Essentially, that's like the burning fee or whatever. Each DVD retails for $15, even though DVDs don't really exist anymore. If x is the number of units produced, answer the following terms of x. Write the total cost as a function of a number of units produced. So what is your cost function for the situation?
10,000 plus 3x.
Yep, 10,000 plus 3x. Perfect. So $10,000 plus $3 per unit. Okay. What's your revenue equation? $15x, right? You're getting $15 per DVD sold, right? That's your revenue. You're already jumping ahead there, Langley, for profit. Profit, we should know, if you guys want to be finance majors or business, profit is simply revenue minus cost. Whatever you bring in, subtract the cost, that's your leftover profit that you take home. So in this case, we want to do what is r of x minus c of x. So what is 15x minus 10,000 plus 3x? Make sure that's in brackets because it's really 15x minus 3x. So your profit equation simplifies to the following. 12x minus 10,000. Okay. So what that means is that you technically, in terms of per unit, you guys will make $12 per DVD. The DVD just costs $3, right? And then it's $15 that you're charging, so you make $12 per DVD. But we're in the hole by 10K to start, right? So we got to get out of the hole first in order to have a positive profit. Okay, turn the company's profit for 20,000 DVDs that are produced. So if they do 20,000 DVDs, so we do that profit, we just simply go profit is 12 times 20,000 minus 10,000. So it's simply 240,000 minus 10,000 for a profit of 230,000. So if you can crank out 20,000 sales, you're in good shape. Okay, and we will stop there.